Hi everyone. Good afternoon, guys. Right, very good afternoon of you. How are you all, everyone? Hope you are all doing well. So, all of you had your lunch or not, everyone? So, we'll be continuing our discussions on this quick revision series of this strength of materials, right? Okay. So, until this strength of materials quick revision is over, it will be doing it, right? Meanwhile, alternate days we are doing the SOM quick revision, right? Alternate days we are doing which one? This so Monday, Wednesday, and which one? Friday. Monday, Wednesday, Friday we are doing this SOM quick revision. Next, Tuesday, Thursday, and Saturday we are doing which one? This PAQ series, right? As na? So that that survey and this highway are running now, na? As na? Once they are over, I'll be starting which one? This question solving sessions of this SOM also, right? Okay. So meanwhile, some of this quick revision sessions of this strength of materials also gets over. You can say we just right, isn't it? Right. So here, anyone having any doubts in our discussions up to yesterday's class? Anyone, all of you? Anyone having any doubts in our discussions anywhere? All of you. Anyone having any doubts in our discussions? All of you? Right. Start. Okay. No doubts? Okay. If no doubts, we'll proceed. Right. So this is some quick revision session we'll be having. So all of you, welcome to Unacademy. Let's crack it, right? Now, so this is my profile. You can follow my Twitch, and this is the referral code, right? What is the referral code? RPC will you have to use, right? These are all the toppers, right? Those who have secured AR1 in GATE 2024 from Unacademy. And now these are the latest batches we'll be having, right? Pavan, good afternoon. So Pratista batch, it was started on 18th August yesterday only. Irrigation by KPSR and structural analysis by Abhishek Shore was started. So what is that referral code you have to use? Tell me, right? RP Civil is the code you have to use, right? Voice is too low. Increase the volume. Increase the volume. Isn't it? Or you can just use. Is it voice problematic for all? So I am using that same which is provided by this Unacademy only. Or you try to use earphones, right? Try to use earphones, Vishal. Right. Shikhar batch. So this Shikhar batch for this 2026 aspirants also started with the same irrigation and this structural analysis, you can say. So what is that a referral code you have to use? RP Civil. Okay. Now, so these are all the books you will be getting, right? These printed books delivered to your home within 15 days of your subscription, right? So now these are all the things we have seen in the first lecture, second lecture, and this third lecture. What is it we have seen? You can say this stress strain curves, right? Various stress strain curves we have discussed now. Factor of safety, margin of safety, right? True stress strains, their relations we have seen, as no, up to this 26th point we have done, right? Now today's class, this lecture for SOM quick revision. So we'll see which one these elongations mostly we must start, right? Yeah, yes, right. Yeah, in YouTube it is lesser obviously, right? Okay, I'll try to ask these Unacademy fellows that what can be done. So I'll try to purchase external mic, right? Okay, right. I'll try to find out what is the solution. Don't worry. Okay. Now these elongations mostly we'll try to do it, right? 26 points gets over now, is or no? So now 27th point, if you just observe it, what is it? 27th point, you can say elastic constants. If you just observe, right? What are these various elastic constants? So these elastic constants are obtained from where? Tell me. From this Hooke's law they are obtained, na? What is it Hooke's law, if you remember, all of you? What is it Hooke's law? That Hooke's law is nothing but your stress is directly proportional to this strain, na? So therefore what is it, you can say stress by strain is equal to the some constant or not, right? Stress by strain is equal to some constant, right? So that constant is nothing but your which one? This elastic constant, if you just observe, right? So what are the different elastic constants you will be saying if you consider Young's modulus? So what is that Young's modulus, you can say? Right. Young's modulus, if you just observe it, what is that Young's modulus if you just consider, tell me. Now it's okay. Young's modulus, if you just consider, right? What is the Young's modulus? E will be equal to, that is your normal stress divided by this normal strain, na? Is that no? Young's modulus is nothing but your normal stress divided by which one? Normal strain. Okay? Normal stress divided by this normal strain, if you just observe, right? So what is that a normal stress? You can say that is your sigma symbol we are giving, and what is that a normal strain? We are giving the symbol young. Epsilon is the symbol we are giving for this normal strain, na? As if you just observe, right? Isn't it? Now rigidity modulus, if you just observe, so you can call it as okay, Pavan. Rigidity modulus, or you can also call it with which name? Tell me. That is your shear modulus, na? Rigidity modulus or this shear modulus, right? What is the symbol we are giving for this? You can say yes. Hooke's law is valid within elastic limit and up to this proportionality limit only. Yes. Hooke's law is valid up to proportionality limit only, right? Yes, absolutely, right? That's G, or you can use the symbol C, or you can use the symbol N also, no? Any one of these three symbols will be using, na? So that is equal to which one? You can say it is nothing but your shear stress divided by which kind of this strain? You can say that is your shear strain, na? Shear stress divided by this shear strain, right? That is your tau divided by which one? This gamma is the symbol we have given for this shear, right? Now what is that? You can say if you just observe. Next, bulk modulus, right? What is that bulk modulus? Bulk modulus, which symbol we are giving? K is the symbol we are giving for this bulk modulus or not, right? So what is the bulk modulus? If you just observe, you can say that is your normal stress, na? Bulk modulus is nothing but your normal stress, right? But which kind of this stress? You can say that is your hydrostatic pressure, na? So in all directions, if this normal stress is the same, right, then only you can consider that or not. Yes, na? Now normal stress divided by which one? This volumetric strain, you can say, right? Normal stress divided by this volumetric strain, right? That is your sigma divided by which one? This epsilon v, right? So like that we are having these elastic constants. Now if you just observe, like this will be having these elastic constants or not, right? These are the different types of these elastic constants you are having, you can say. Isn't it? Now so if we just consider, right, what is that? You can say the relations between the elastic constants. You can say what are the various relations between the elastic constants? If you just observe, right, if you consider E equal to which one, right? Will Poisson's ratio be elastic constant? Yes, yes, absolutely. Poisson's ratio is also an elastic constant, right? So that if that value is, if any particular parameter, generally what is the meaning of constant? Tell me. Constant means which is the same for a given particular material, na? So no, if you are taking a steel, for this steel some parameters are constant, right? Which parameters are same, whatever the situation, whatever the condition it is in, so then these parameters are called as your which one? This constants, right? And if they are valid within the elastic limit only, then these are called as your elastic constants, if you just consider, right? Like that. Isn't it understood? So now what is it? You can say E equal to 2g into 1 plus mu. Yes, that is the relation, right? E equal to what is it? You can say 2g into 1 plus mu. And what is another relation? If you just observe, E equal to that 3k into what is it? You can say 1 minus this 2 mu, na? E equal to 2g into 1 plus mu, right? E equal to 3k into which one? This 1 minus this 2 mu, right? So these are the relations we are having or not, right? So now tell me what is the relation between these three parameters? If you just observe, what is the relation between these three parameters? If you just observe it, this is involving, first one is involving only 2, right? E and G. Second one is involving only the 2, E and K. And what is another relation involving all the three? You can say if you just observe, E equal to that 9 kg divided by which one? This 3k plus this G, na? So now 9 kg by this 3k plus this G, you can say. And what is that? If you wanted to get the Poisson's ratio mu from that, what is it? You can say that is your 3k minus this 2g divided by which one? This is 6k plus this 2g, right? So can we write it like this, everyone? Can we write it like this? Yes, 9 kg by this 3k plus this g, if you just consider, right? Like that. Isn't it clear? Yes, na? Right? Clear now? Now, is not now next. What is another one? If you just observe right here, some Poisson's ratio. So here, if you just know that a Poisson's ratio, you can say right that mu Poisson's ratio, right? What is that? First of all, what is that a Poisson's effect? You can say that a Poisson's effect. What is the meaning of this Poisson's effect? If you just observe, Poisson's effect is nothing but your, so a particular load is acting in one direction, right? What it will do, tell me? It will try to increase the dimension. If it is a tension, it will try to decrease the dimension. If it is compression, na, is that no? So whenever there is increase in one dimension, right, that will result in a decrease in another dimension, na, is that no? Is no? So Poisson's effect I am asking, right, not the Poisson's ratio. Whenever I am asking Poisson's ratio, then you can say that lateral strain by this longitudinal strain, that is okay. But I am asking what is the Poisson's effect, right? Poisson's effect is nothing but, so increase in one dimension, okay? Increase, yes. Increase in which one? This one dimension. Due to which condition, tell me? Increase in one dimension, right? Due to what, tell me? Due to load, right? Due to which kind of this load, tell me? Due to this tensile load, na? Due to this tensile load in that direction. In that direction only, no? Yes or no? In that direction will cause what? When one direction is increasing, right, other direction will cause which one? Will cause decrease in other directions, na? Will cause the decrease in which dimensions, tell me, right? Which will cause decrease in these other dimensions or other directions, na? Will cause a decrease in these other dimensions or these other directions, you can see if you just observe, right? But is it always increase only? There can be decrease in one dimension also possible or not, right? Whenever there is a decrease in one dimension, right, it is due to this compression, na? Will cause which one? This, if load is decreasing one dimension, right, so other dimensions, right, what happens? Increase will happen, right? Other dimensions, right, what happens? You can say that increase will happen, you can say. Got it now? That is your Poisson's effect if you just observe, right? Now what is that Poisson's ratio? You can say, what is that Poisson's ratio if you just consider? Then you can write that expression, right? Poisson's ratio, right? What is the symbol we are giving? Mu is the symbol we can give, or 1 by m is the symbol we can give, or nu is the symbol we can give, right? So various symbols we can give if you just observe, right? So what is that mu? You can say if you just observe, minus of which one? You can say lateral strain divided by which one? Lateral strain divided by which one? This is a longitudinal strain, na? Lateral strain divided by which one? This is a longitudinal strain or not, right? Yes, no? Right. So like that, if you just observe it, what are these Poisson's ratio values? You can say, so here if you just observe these values of which one? This E, Young's modulus, and this Poisson's ratio mu. Now if you know these two values, you can get the other values, na? Is that no? Yes, yes, for engineering material it will vary from this 0 to 0.5, and it can be negative for some of these materials in general, right? If you consider only engineering materials, now it is varying from which one? This is 0 to 0.5, you consider it 0 to 0.5, you can say if you just observe, right? Is it right? Got it? Now, so here, what are the values of this E? You can say if you just observe Young's modulus. So that is for this steel, you can say, right? Material if you are considering, na? Okay, directly I will be writing the Young's modulus E of that material, I'll write directly instead of writing material separately and this E value separately, right? What I will do is, right, I'll just do it directly. So what is it? You can say E of this steel. What is that Young's modulus of this steel? You can say that is your 200 GPa, na? Or 2 into 10 power 5 MPa, right? Now Young's modulus of which one? This aluminum. If you just observe, what is the Young's modulus of this aluminum, right? That is your 70 GPa, na? So now Young's modulus of which one? You can say that is your brass. If you just observe, what is that for this brass? It is your 100 GPa, na? 100 GPa. Now Young's modulus of which one? This bronze, na? Young's modulus of which one, you can say that bronze or not, right? So if you consider this Young's modulus of this bronze, okay, Young's modulus of this bronze, right? What is the Young's modulus of this bronze? You can say that is your 80 GPa, na? Yes, no, that is your 80 GPa, right? So next Young's modulus of this copper, right? What is that copper? You can say. So if you are putting in the backward direction and rub it, it will be erased like that. Young's modulus of this copper is how much? That is your 120 GPa, na? Yes, no? Right. Lesser Young's modulus is significant or lesser slope of stress strain curve means signifies what or lesser lesser slope of the stress strain curve. Yes, lesser slope of the stress strain curve means lesser Young's modulus only. It means its elastic behavior is lesser, right? Only for smaller loads it will be acting like elastic, right? For higher loads it may not act like elastic, right? That is the meaning of it, right? So higher stresses plastic, right? Lesser stresses only elastic, right? If the Young's modulus is lesser, right? Now what is the Young's modulus of which one? This is a diamond, you can say. Actually it is varying, right? But generally what is that we are taking? Tell me. This is the strongest material ever we found in the universe till now, na? So 1200 GPa, that 1200 GPa will be which one? This is the highest, you can say. It is the highest value of this Young's modulus for a diamond, if you just observe, right? Like that. Is it clear? Yes, na? Note these values and tell me. Then I'll write these mu values, Poisson's ratio values. Then we'll enter into the elongations if you just consider. Right? Noted? Now, so what is the meaning? What are the Poisson's ratio of this cork? You can say Poisson's ratio of this cork will be 0. That a Poisson's ratio of which material? General engineering materials only I am writing, right? Thousands of materials we can write, but okay, only few materials will write, right? So Poisson's ratio of this concrete is what? 0.12, which one? This is 0.3, you can say, right? Pressure vessels are is removed from the gate syllabus, right? It is removed from the gate syllabus, you can say, right? Yes, na? Now what is that Poisson's ratio of this cast iron? Tell me, right? What is that? 0.22, what, right? 0.22, this is 0.3, right? Yeah, that is not there in, that is not there, okay, Vishal. And next Poisson's ratio of this aluminum, right? What is the Poisson's ratio of this aluminum? If you just observe, right, that is your 0.33 now. And Poisson's ratio of this steel will be how much, you can say? Poisson's ratio of this steel will be 0.272, which one? This is 0.3 na? So no. Next Poisson's ratio of this brass, right? So Poisson's ratio of this brass is what? 0.34, if you just observe, right? Now Poisson's ratio of this gold is what? 0.44, you can say, right? Right. So Poisson's ratio of which one? This glass, right? Few materials you try to remember, right? Which we'll use generally in our civil engineering aspects, right? 0.22, which one? This is 0.27, right? So what is it, you can say? Incompressible materials, right? What is it, you can say? Poisson's ratio of which one? This incompressible materials, right? Poisson's ratio of this incompressible materials is given as which one? This is 0.5, right? So incompressible materials means, right, what are these? Tell me. Examples of this incompressible materials are which one? This is a paraffin. Yes, na? Yes. Examples are which one? This is a paraffin. Next, what is it, you can say? Rubber and this clay. These are some of the examples of these incompressible materials, na? These are some of the examples of these incompressible materials or not, right? If you just observe. Is it clear now? Incompressible materials? Yes, na? Isn't it? Incompressible materials that we'll be having like this or not? If you just consider. Yes, na? Got it? Clear these values if you just observe. Yes, na? Yeah, sponge also you can say it. Yes, this for that also you will not be having compression, right? Yes, yes, absolutely right. Water also, right? Many materials. That is why I have written etc. If you wanted to add, you can add hundreds of materials, right? If you try to write hundreds of material, this entire course will become for that only. We'll just write one or two and we'll put etc. Just we'll write one or two and we'll put etc. That's it. Okay. Now, if you just observe it, we will be going for which topic you can say. If you just consider elongations, will be going for sir. Elongations will be going for, you can say, right? What is that elongation? If you just observe, whenever you are having a member like this, neglect self weight, right? You will be having this load P like this. Yeah. Okay. Either it is represented like this in the form of which one, this tension you can say, or it is represented in the form of which one, this compression you can say, whatever it is. It's not. Or you can have representation in this manner also, right? Various representations will be having, right? So in whatever the manner, right? So what does it mean? It means that in whatever the direction that a load is acting, so what is that elongation? Tell me. So what is that elongation, change in a length? If you just consider, tell me. Change in length, that delta L will be equal to P is the load applied over which, over this length L it is acting. A is the area of cross section, E is the Young's modulus. So here plus or minus we have to take it, na? Plus or minus we have to take it, right? So when we will be applying the sign convention as a plus, tell me if you just observe. When will be taking the sign convention as this plus? Plus is for which one, you can say, if you just observe it, plus is for this elongation, na? Plus is for this elongation under which condition, tell me? Plus is for the elongation under this tension, na? Minus for which one, tell me? Minus is for which one, this elongation means that what is it, you can say? Contraction, na? Yes or no? So this is a contraction under which one, this compression, na? Contraction under this compression, you can say it like that. Yes, note this and tell me. Then we'll see other examples. How the expression came means, right, that is discussed in the full length course, right? This is not the full length course, this is quick revision session, just a recap, right? So in the full length course I have discussed, na? But okay, I'll just tell you briefly, you do that. Young's modulus is equal to which one? This is stress by this strain, na? So I'll tell you briefly, you try it. So Young's modulus is equal to that stress by this strain, right? What is that stress, you can say? Okay, I'm writing here itself. Stress is nothing but your load by this area, is not? Strain is nothing but your delta L change in the length by this L, right? When you simplify this, right, you will be getting that expression, right? Is not delta L by L, you take it to left hand side, you take it to right hand side, L you take it to right hand side, then you will be getting that expression of PL by this E directly. Okay, right? Clear? Done, everyone? Right. So shall we move to the next one? This is your 33rd, right? Next one is which one? This is 34th, if you just have, right? So what is that, you can say, whenever it is a stepped bar given, what is the meaning of this stepped bar? Tell me. It is having the same condition, or it is same length and this is same. Okay, what is that? You can say this is your length L, na? In that expression, right? What is that length L? You consider this is your length L, if you just have, right? So this is your cross section A. Okay, this is your cross section A, that is your length L, right? Here also this is your cross section A, and what is this considered? This is your length L, you can say, right? So this is your length L, and what is that A? You can say that A is your cross section if you just observe, right? Isn't it? Right. Like that. So stepped bar, right? What is the meaning of this stepped bar? You can say composite bar, na? Stepped bar or this composite bar, right? What is it? A stepped bar or this composite bar? You can say. So this is, yeah, non-prismatic section, correct, right? So with intermediate forces or without intermediate forces, if you just observe, without intermediate forces, right? Without intermediate forces, right? So with intermediate forces, we'll say again, right? So whenever it is that without intermediate forces, right? What is that? You can see if you just consider. Let us take it like this. If you just observe, some member will come here, right? Next after that, right, what is it? You can say some other member will come, right? Is na? Next, what is it after that, right? Some other member will come, right? Here these three members are having this three different cross sections or same cross sections they are having? Tell me, are they having the same cross section or different cross sections? If you just observe, they are having these different cross sections, na? So first one, what is it? You can say it is having area of cross section A1. So this is length, how much you can say for the first member, that is your L1. And what is your Young's modulus, you can say that is your E1, right? So all are different materials also, it can be possible now. Now this is your which one? This L2 you can say is the length of this second member, and what is the area of this cross section of this second member A2, and what is the Young's modulus of this second member E2. So here similarly, right, what is it considered? This is your length of this third member L3, and what is that area of cross section, that is your A3, and what is the Young's modulus, you can say that is your E3, right? So finally, what is the delta L you are getting? Tell me. So do you have same load or do you have different load? If you just observe, we have this same load only, no, plus or minus P into what is it? You can say that delta L is equal to which one? This is delta L in the first member plus this delta L in the second member plus this delta L in the third member plus so on. If n members are there, it is a deformation of these n members you can add, right? P into what is it? You can say L1 by this A1 E1 plus what is it? You can say L2 by this A2 E2 plus L3 by this which one? This A3 E3 plus so on. So if area of cross sections are same, you can take this out, right? If Young's modulus material is same, you can take this out. If lengths are same, you can take this out, right? Like that. We can do this in different manner or not, right? Whichever the manner you want. Yes, na? 35th one, you can say stepped bar. Stepped bar means that same cross section or it is a non-prismatic cross section, you can say prismatic or non-prismatic cross section. Stepped bar or this composite bar means, right, non-prismatic cross section definitely, right? Stepped or which one? This composite bar. Stepped or this composite bar having which one? This with the intermediate forces, na? With what condition? Tell me. With what condition? If you just observe, with intermediate forces or not, right? With intermediate forces will be having, you can say, right? So whenever these intermediate forces are there, right, do you give guarantee that always they will be tension only, always they will be compression only, sometimes they will be tension, sometimes they will be compression, and there is a possibility or not, right? So here what is that? You can say that delta L is nothing but your plus or minus delta L1. So here plus or minus we will use only for which one? This is the entire one if you just observe, okay? But here plus or minus delta 1 plus or minus delta L2 plus or minus that is your delta L3 plus or minus so on. So do you guarantee that which one is tension, which one is compression? No. But here in the 34th point, either all are tension or all are compression. Is not? Either all will be under tension or all will be under compression. So for all either plus sign, for all either or minus sign. But for this some members plus sign, some members minus sign. That is why plus or minus we have written for which one? This individually. Okay, understood now? Why we have given this plus or minus sign for individual values, right? Do you understand, all of you? Okay, just for an example, right, here we cannot write the generalized expression. Just for an example, if you can write it, what is that? You can say This is your first member, you can say. This is your member A. Okay, so what is that? Okay, area of cross section is which one? This A1 member, right? For this, so for this second member, right, that area of cross section is your A2, and for the third member, right, what is that? You can say that area of cross section is which one? This A3, you can say. And now, so here lengths also will be same or different if you just observe, right? So lengths may not be same, right? L1 first member length, L2 second member length, L3 third member length, and Young's modulus value is also, right? This is E1 for the first member and E2 for the second member, and what is it? You can say that is your E3 for the third member, right? There can be possibility or not, right? But along with this, right, up to this it is the same as that of your 34th point, previous one only. But what is the only difference you are having if you just observe? The only difference is here load P1 acting, you can say, if you just observe, right? At the intermediate locations also the loads are acting, right? That is your P2 if you just say, right? So now what is that? You can say this is your P3 load acting, right? What is that? Again you can say this is your P4 load acting, you can say. Understood? That is the only difference. So the only difference from the 34th point to 35th point is which one? Tell me. Only one load is acting in case of this 34th point, but for this 35th point, right, what happens? Tell me. Loads are acting on total, all member together, only one load is acting, or at different junctions different loads are acting, right? At different junctions of these members that different loads are acting, yes or no? Isn't it? Understood the difference between that one and this one, all of you? Clear? Is the difference clear for everyone? All of you? Is not? Right. So now what is that we can do here if you just observe? Here first member you consider separately, second member you consider separately, and what you can do, that a third member you consider separately. So what is that we are having, right? First member P1 here you are having, right? To balance that, right, what is that you are having? You can say this is your same P1 only we are having, nice or no? This is the same P1 only we are having, you can say. Fourth member if you just observe, right, third member if you just observe, this is your P4 compression, right? To counteract that, another P4 it will be acting like a compression, and this is compression. This is first member is under which one? This tension, you can say. What is that second member? You can say if you just observe. So this P2 is on the right hand side, you can say that P2 is on which one? This right hand side. When P2 is on the right hand side, right, what is that? A net force, you can say. Net force we should have here in the right hand side is P2. So what is that? You should have, if you are adding these two, P1 plus P2 you are having, right? But if you are adding, if you are making it as a P2 minus this P1, if you are adding these two, what it will happen? P1 plus P2 minus P1, minus P1 plus P1 cancel, P2 only will be left, right? At this first junction, P2 only will be left, right? Like that. Is that clear? Here also, right, what is that? You can say if you just consider that same. So this is right side P4 you are having, right? Right side P4 you are having, right? Left side what is that? P3 na. So if you are adding this, right, this is left side P3, right? P3 minus this P4 we are having, right? So means this P1 minus P2 minus P1 and P3 minus P4 must be same, right? For that, what is it? You can say P2 minus this P1 is equal to P3 minus this P4 na. That condition must be satisfied or not? Is not? This condition must be satisfied or not? This condition must be satisfied, you can say, if you just have, right? Okay, this is your which one? This positive delta L is delta L1 is a positive or negative? Tell me for this. This is your positive, this is your negative, and this is also which one? This is negative na? Isn't it? Compression and negative, and this is tension positive, you can say, if you just consider, right? Like that. Is it clear? Is it clear now? Is it clear? Under this elongations, right, one more important one. Got it? Once clear, note down, once not, tell me. Compression will be taken as negative always, and this tension will be taken as a positive always, you can see, if you just observe, right? Yes, no? Right? Done? Others also done? Next. 36th if you just observe, right? Now, what is that 36? Where is that P2 negative? Did I mention P2 negative? P2 minus this P1, right? P2 minus this P1. P2 minus this P1, right? P2 minus this P1, right? What is it you can say? P2 minus this P1 we are having. Yes, now P2 minus this P1 we are taking, right? Did I mention that it is negative? See here, P2 is in this right hand side direction. P2 P2 is for which one? This one. P2 is acting for this right side. Yes or no? P2 is acting for this right side, you can say. So, but at this, okay, if you consider this is your A, this is your B, this is your C, this is your D, you can say. Where did I mention P2 is compression? Did I mention P2 is compression? Second load, second member. That is second member. Second member, na? Yes or no? Second member. Are you saying about the second member? I did not get your doubt exactly, Pawan. Yeah, tell me, Pawan, what's your doubt exactly? Yeah, at this point B, it is already given. It is already given in the question. That example, it is already given in the question, right? That P2 is right hand side, P3 is left hand side, right? So like that, that is given, right? Yes, na? That is given, right? So yeah, P2 and P3 together are creating compressive effect on this second one. It is there, na? Yes, na? You can observe from this P2 and this P3 direction, na? Is that? Because P2 is acting in this direction, P3 is acting in this direction. What kind of effect they will create? Tell me if you just observe. Understood? Why it is compression? Right. So here, so what is it next? You can go for if you just observe, right? Tapering, right? Elongation of which one? This is tapering rods. So tapering bars, if you just observe, na, whenever it is a tapering bars of which one, you can say that is your circular type, na. Circular type, na, son. So circular type, you can say if you just put, whenever it is your circular type, right? What is it you can say if you just observe? This is your circular one, right? It is changing from which one? This one diameter to this other diameter, na. Either it is tensile in nature or it is your compressive in nature, na. Yes or no? We can have anything, you can say if you just observe. This is your length of this member, and what is the diameter you are having, right? This is your diameter d1, na. And what is this one, you consider? This is your diameter d2, na. Now what is the delta L? If you just observe, delta L is equal to that 4pl by this, what is that, you can say pi e d1 d2. It's not pi e d1 d2. That is for which one? This is circular tapering, right? Now what is the second one, you can say? What is the second one if you just observe? Rectangular type, na. Rectangular type tapering only. But what happens, you can say rectangular type also, right? In this, which one is the same if you just observe? Same thickness, na. Only which one is varying, you can say that is same thickness. Same thickness, and what is that, you can say that is your varying width, na. Same thickness and this varying width or not, right? Same thickness and this varying width, you can see if you just observe, right? So what is the same thickness and this varying width if you just observe? Right. So here if you just observe, if you just observe it, it will be in this manner, na? So now what is this one considered? That is your thickness T, that is your thickness T if you just consider. And what is this symbol we are giving for this? B1 or capital B symbol? Capital B, small b, or which symbol you wanted to give, tell me. Okay, capital B, small b symbol will give, right? What is this one considered? This is your length L. And what is that delta L if you just observe? Delta L is equal to, what is it you can say? PL divided by which one? PL divided by which one? That E into that T into, right, what is that? Capital B minus this small b into, what is it you can say? Log capital B divided by this small b to the base C, na? Isn't it? That is what is, na? No. So next, what is another type if you just observe? Third type will be which one? This is square type. What is the meaning of this square type? You can say at one side bigger square, at another side, right, what is it you can say? Smaller square, na? Yes or no? One sec. The diagram came wrongly. One sec. So one end bigger square and other end, what is it you can say? That is your smaller square, na? One end bigger square and other end, what is it you can say? Smaller square, or not, right? So this side, what is that you can say? If you just observe, this side it is your A. This side it is your A, you can say, right? So what is another side you can say? That is your B, and this is your which one? This B, you can say, right? And what is this, right? This is your small L if you just observe, right? So what is that delta L? You can say that delta L will be equal to that P into L divided by which one? This A into that B into that E, right? That is deflection under which one? This square tapering, right? So same subjected to load P here only, no? Everywhere that we are considering this, it is subjected to a load P, you can say, if you just observe, right? Got it now, everyone? Under what is that? What is that? Is it clear, everyone? That elongation, right? One more point we'll write under this elongation. With that, elongation gets over. Okay? Elongation under this self weight, if you write now, all the elongations gets over. Okay? Next we can go for which one? Thermal stresses in the next class. Okay? After writing this volumetric strain, thermal stresses in the next class we can go for. Simply. Note this and tell me. Clear? Once clear, note down. Once noted, tell me. Done? Right. So here what is it you can say if you just observe it? That is your elongation due to self weight, na? Elongation due to self weight, right? What is that elongation due to self weight? You consider that delta L is equal to, that is your W into L divided by this 2AE. Simply WL by this 2AE, right? This is a general expression, right? Do we consider any extra load, or you don't consider any extra load, right? You don't consider this any extra load, na? So what is the W? You can say W is nothing but your total self weight, na? W is nothing but which one? You can say W is nothing but your total self weight, or W is nothing but your total self weight, you can say, right? Now, so what is it? Delta L you are having, right? That is your WL by this 2AE, is not? That is also equal to, right, what is it you can say? Gamma L square by this 2A. For what? Tell me. This is for this cylindrical. This is for which one? This is cylindrical, you can say, if you just observe, right? Is not? Now the delta L is equal to, right, what is it? You can say, if you just observe, that is gamma L square by this 6a. This is for which one? This cone. This is for this conical, right? As na, this is for this conical, you can say. Conical means it will be like this, na, as na, the diameter capital D. And what is that? A, you can say A is the area at which location? That top location of pi by 4 into the d square. But for this, right, it is the same everywhere or not, right? It is the same everywhere, you can say, right? Is that clear now, everyone? Up to this point, anyone having any doubt? So with this, the elongations gets over, right? So next, in the next class on Wednesday, we'll see about which one? Thermal stresses. Okay, clear now, all of you? Clear now, everyone? Thank you, all of you. Have a good day. Thank you. I'll be closing the session. Okay. It is not yet closed. Okay, okay. Yeah, tell me what you did not understand. Tell me, Sudhi. Tell me, Sudhi, what you did not understand. This is the self weight elongation under the self weight or elongation due to the self weight. So whenever you are considering a member, na, this is your member. For this member, you will be having W as the total self weight. What that will do, whenever you are hanging a member like this, that a self weight will try to pull it in the downward direction, or it will not pull. It will try to pull it in the downward direction, na? Or so this is under this tensile effect it will come, na? But suppose if you are having it like this, right, what that self weight for this member will do? It will try to compress this member, na? It will try to compress this member, na? These are expressions. These are the formulae for this elongation. These are the formulae for this elongation, right? Are you saying how they have come? Are you saying how they have come? Are you asking how they have come, or these are the expressions, right? These are expressions, right? How they have come? You have to consider general expression, okay? Generalized expression you have to consider it at a distance x, okay? At this x, this is your which one? This is dx. This is your dx, okay? You consider this a general expression and write the generalized expression is there, na? Delta L is equal to that PL by this AE. In this, you consider, instead of this load P, you consider it as this self weight up to that point, right? Self weight up to that point you consider. And gamma is what? L you consider it as which one? This x only. P, in place of P you consider it as the self weight above that W at this x portion, right? A you consider it as A only. Then you simplify it, right? Then you will be getting that formula. So that weight you have to substitute in terms of density, na? Weight you have to substitute in terms of this density. Y means, Y2K means, right? So here it is, when you are deriving it, you will be getting it, right? Y2K means, right? Based on the expressions, you will be getting it actually, right? Based on this expression derivation, you will be getting, right? Because it is your x, na? Whenever you are integrating over for this, some multiplication of x will come now here. So here, what is that self weight? Tell me, this is your Wx is the self weight it is having, na? Yes or no? What is it we can write? So here, that is your delta x is equal to, right, what is it you can say? So individual Wx into that, what is that L you can say? That is your x, if you just observe, that is your x divided by this A. Area is nothing but your which one? That you can take it, right? So these terms no problem. When you are integrating it, na, x will become which one? This x square by this 2, na? X square by this 2, right? This is how that 2 comes in the denominator, okay? From the integration part, that 2 will come into picture, right? Like that. Is it clear? Is na? Okay. Thank you. Right. You asked, you said, okay. Right. Thank you. Have a good day.